Okay, continuing with section 8.1 of chapter 8, gases, we're talking about atmospheric pressure. All right, so atmospheric pressure is going to vary depending on the location. All right, so at sea level, it's 1 atmosphere, 760 millimeters of mercury. But at higher altitudes where the air is less dense, it's going to be less. So here at the top of this mountain in this picture, it shows that it's 0.7 atmosphere or 530 millimeters of mercury. Now, atmospheric pressure can also change with variations in weather. Sunny days are indications of high atmospheric pressure. Rainy days are indications of low atmospheric pressure. Now, atmospheric pressure, as I said, varies with location as well. Okay, sea level is 760. Below sea, or at low points like at the Dead Sea, it's higher. Okay, below sea, the pressure increases because of the weight of the water. So now at higher altitudes, the pressure decreases. All right. So these are some places of high altitudes where the pressure is quite low. What is 475 millimeters of mercury in ATM? So this is less than 760, so it's going to be less than an atmosphere, and so B would be the correct answer. 2 atmospheres in millimeters of mercury. So 1 is 760, so 2 would be 1520. The downward pressure on mercury in a barometer is the same as the atmospheric pressure. A water barometer is 13.6 times taller than a mercury barometer because mercury is 13.6 times denser than water. So water is less dense than mercury. Boyle's law is the pressure volume relationship. So when you have 4 variables, 4 properties for gases, so if you keep the 2 constant like temperature and moles, then you can study the other 2. So they are in opposite, they are related in opposite fashion in the sense that when volume increases, the pressure will decrease, or when pressure increases, then the volume will decrease. Okay. All right. So Boyle's law can be seen here with these diagrams. You can see that the initial pressure and initial volume, 1 and 4, and then the piston was brought down. So the same gas particles were now squeezed into a smaller space, a 2-liter space. So they're going to collide with the walls of the container a lot more. So the pressure goes up. All right. So if you multiply the initial pressure, initial volume, you get 4-liter atmosphere. If you multiply the final pressure and final volume, you also get 4-liter atmosphere. So that means the pressure volume relationship, PV, gives you a constant value. So you can then derive the relationship that P1, V1 is equal to P2, V2, where the initial pressure times the initial volume equals the final pressure times the final volume. So this is the form that Boyle's law takes. All right, so you can see in all of these, when you multiply the pressure and the volume, you get a constant unit, or a constant number rather. All right, 16-liter atmosphere. So Boyle's law takes the form P1 V1 is equal to P2 V2 provided temperature and moles are kept constant. Breathing is nothing but Boyle's law in action. All right, as the diaphragm contracts and moves downward, it creates more space in the lungs. So the volume is going up, volume is increasing, pressure decreases. So when pressure decreases, the outside air is at a higher pressure, so the pressure must equalize inside and outside. So air rushes in so as to equalize the pressure inside and outside. Okay, so that's inhalation, air flowing into the lungs. During exhalation, what happens is the diaphragm is moving upward as it relaxes, so the lung volume, lung space now decreases. Okay, so when the volume decreases, the pressure inside the lungs are increasing. All right, so and the pressure outside is less, therefore that forces all that excess air to come out. Okay, and so that's exhalation. All right, how do you solve gas law problems, especially Boyle's law? So start by organizing what you have in a table and then rearrange the gas law to solve for the unknown quantity. So if you're given P1, V1 is equal to P2, V2, you have to be at least given 3 variables to solve for the unknown variable and substitute the known values into the equation to calculate the unknown. So here in this particular reaction, you're given the initial pressure, which is 550 millimeters of mercury, the initial volume of 8 liters. You're also given the final pressure and asked to calculate the final volume. This is Boyle's law because temperature and moles are constant. So what do you anticipate? The pressure has gone up, therefore the volume must be lower than the 8 liters. Okay. All right, so P1 V1 is equal to P2 V2. Okay, so you're solving for V2, divide both sides by P2. So you get rid of the P2 on one side. So V2 becomes P1 V1 divided by P2. So 8 times the 550 divided by the 2200, and that gives you 2 liter. And that's the prediction that, excuse me, as the pressure goes up, the volume must come down. All right, so here a sample of gas. The initial pressure is 600 millimeters, initial volume is 12 liters. You want to find out the final pressure when the final volume is given. So the volume has gone up, so the pressure must come down. It must be less than the 600. Okay, so it could be these two choices, A or B. Okay, all right. So set the problem up. So 600 times 12 divided by the 36, and you get 200. So the answer is A. So here in this study check, you are given a sample of gas. This is how it is initially. What happens on this sample if your pressure is decreasing? So if you pull the piston up, pressure is decreasing, that means volume has increased. So that would be B. Pressure is increasing, so you push the piston down. All right, that increases pressure, and that means that volume has decreased. So it is A. All right, a sample of helium gas has a volume of 120 ml and a pressure 850 millimeters of mercury. What is a new volume if the pressure changed to 425? So the pressure is decreased, the volume has to go up. It will be more than 120 ml. All right, so P1 V1, and you divide it by the P2 and you get your final volume. All right, a sample of helium in a balloon has a volume of 6.4 liters and a pressure of 0.7. So the pressure has gone up. So which balloon would that represent? If the pressure goes up, the volume must decrease, so it has to be A. And we'll stop here.